Good morning, everybody. Last time we were discussing about different combination logic circuits and their relevant logic functions. These logic functions are also called as Boolean expressions. So the one example which we did in our last lecture was as you can see on the screen. So this was the logic function uh, according to which we developed our logic circuit, which is here. So it's not a difficult thing. You can do it easily. First of all, you have to see how many inputs are there. Here you can see there are three inputs: A, B, and C. So these three inputs you need to tackle. And first you need to perform the multiplication function, which is B dot C inversion and A inverse dot B inverse. So then after multiplication, then you can do the addition, which is A plus B dot C plus A dot B, like that. So the same thing is being implemented here. The first step is all the inversion. Wherever you need inversion, you do the inversions. In the second step, you are doing the multiplication. These AND gates are doing multiplication in the second step. And the third step is last one, which is the addition, and this OR gate in the third step is doing the addition thing. So that's how, if you have a function, you can develop your logic circuit. Or if I give you a logic circuit and ask you to develop the logic function, you can do the reverse as well. Yes, Muhammad Saif. I didn't get your question. Can you speak up? Muhammad Saif, if you have any question, you can ask now. All right, anyway, so this is uh, Muhammad Saif. See, here the function says, if you want to be more clear on the function, see here the function says b dot c. This is one multiplication function. I am just going to put the brackets for more clarity. Before this, there was a inverse plus. This is the plus sign now. And after b dot c, there is one more a dot see A inverse and dot B inverse. So this is another thing. So what I'm saying, that first we have to perform these functions which are in brackets. This is number one, this is number two. So these are the two. As think about how you solve the mathematical questions. If you have some question like this, assume there are numbers instead of alphabets. How you perform? You perform multiplication and division first, and then you go for addition and subtraction. This is the mathematical principles. Okay, so the same is being followed here. So in this function, uh, b dot c inverse, which I have put brackets in that, this one, and a inverse dot b inverse, I also put brackets here. So these two are the multiplication functions. So for from here you can think that you need two AND gates, because AND gates perform multiplication. And After that, if you see there is one, I will change a color and I will show you. See, there is one plus sign here and one plus sign here. So, and you are adding three things together. A inverse plus this factor plus this third factor. So it means you need one OR gate for addition, but that OR gate should have three inputs. Okay. So all of these will come together and they will be added in the last step. Before that, when you are giving input, some inputs are straight. Straight means if it is B is not inverted, it's straight. But here the B is inverse. So it means you also need some NOT gates so that you can inverse your input. So that's why here, if you now look at the logic function, the logic circuit here, you can see that there are NOT gates are also used, one for each input. Three NOT gates are one for each input. So if some logic gate need A, you can give straight to that without any inversion. For example, the first one, B dot C. Let's find out where is B dot C. Which C is in first, Muhammad said? Okay, let me explain from here now. All right, first of all, Muhammad Saif, it doesn't matter if C is first or C. It doesn't matter C is first or B or A. You can put any in any order. The main thing is you have to give that inputs to the gates. See, if I now look at this function which I am circled in red, this is B dot C inverse. So which gate is doing B dot C inverse? It is this one here. If I put number one here, I will put number one here. So number one segment is being performed by this gate number one, which is the AND gate number one. This second part, A inverse dot B inverse, which is 2, it is being performed by this gate here. Okay, now this function here, it needs B dot C inverse. So we can see that B, see this is B input coming in. It is going from here, follow my hand symbol, and then it is going into this gate. So B is you are giving straight to the AND gate. Now it needs C inverted. So you are giving C input here and you are putting in a NOT gate in between so that it inverses the input and then you give it to the AND gate. So this first part of the function you have completed. So you have done it. Now the second part of the function, because we are dealing with the multiplication first. So this is A inverse dot B inverse. So number two AND gate is performing that. Now A is coming from here and you are putting a NOT gate in between so that it inverses the input and then it is going into this AND gate. Follow my hand symbol so you will understand. Similarly, the B input, it is also coming and we are also using a NOT gate here because we need inversion. So NOT gate will invert the input and then it will go into this AND gate. So that's how this is being implemented. The second function, second part of the function is also completed with the second uh, AND gate. Now we have to add all three parts together. This is the first part, this is the second part, and this is the third part. So the output here, the output of AND gate 1, what will be the output? It will be B dot C inverse. This is the output of AND gate 1. Why? Because you see the B is coming from here and B is going into this AND gate, and C inverse is coming from here. These are the two inputs this AND gate is handling, and this AND gate is doing nothing but simply multiplying them. So B dot C inverse is the output of this AND gate. So we can write it at the output. Now what is the output of second AND gate? It is, can anybody tell me? Can somebody want to contribute here? Yeah, A dot B, Amar, but inversion, with inversion, A dot B inverse. Because both A and B, we are putting NOT gates, so it will invert the input and give it to the AND gate. So this is the output of the second AND gate. Okay, now this is going into this OR gate, and this is also going into this OR gate. Both of these are going into this OR gate. OR gate will simply add them. But if we see here, if we look at our function, there are three things. What do you mean by main? Please, either you can speak. We
Yeah.
ask question. Yes.
What mean point A, point B? Multiply what?
Point A and point B.
No,
Which part you
you
referring?
you say A, point B.
A. See, A point means multiply. Yes. See, if I write 3 multiply 2, answer is 6. I can the multiplication sign can also be mentioned by a dot like this. So the dot is actually multiplication. So
Okay,
it also means 6. So both are same. So in digital, wherever you see dot, see you can see in the function, you can see the dot. Dot means multiply. All right. Okay, I hope it is clear. So these two AND gates are giving output like this, B dot C inverse, and second AND gate is giving A inverse dot P inverse, and it is both going into this OR gate. But this OR gate is coming, there is a third input also coming from here. What is that? That is the A through NOT gate, which means A inverse is coming from here. So if you look at the function, we have A inverse here. This is our A inverse. So there are three things which you have to add together. So A inverse is coming from here. I will put the green line here. So that's how the three inputs are coming into this OR gate, and finally you are adding all of these three parts together using a OR gate, and this is your final output function, which is the same as here. So guys, I hope this thing is clear now, how to make a logic function with a logic circuit. So if you have a logic function given, I hope you can develop a logic circuit easily. Is there any questions you can ask?
Yes, yeah, it's clear.
Okay, good. So moving on to the next slide. See, this is the uh, actually this is the truth table of that combination logic circuit. Okay, last time we left here. This is the circuit which we developed from our combination logic circuit, from our expression for the logic function. Using the logic function, we developed this circuit. But this circuit is having how many gates? 1, 2, 3, 4, 5, and 6. 6 gates are here. So more number of gates means more energy consumption, and it will take more time to get the output because each gate takes some time in processing. So the same function can be performed with less number of gates, as you can see here. Here we are using only 4 gates, and this will do the same function. It will provide the same kind of behavior and truth table as the one above. So we do this while designing so that our circuit is small in size, less number of components, so that its power consumption is low and its processing speed is fast. So all of these things can be achieved by using this technique, by reducing the circuit size in design. Okay, now this another example. So this is the what if I should do. Okay, I just I'm just hiding this Boolean expression. Boolean expression means, see, Boolean algebra is the digital algebraic language. Like you study algebra in mathematics with the find the value of x, y, or z, whatever. So you deal with different equations, algebraic equations. Similarly, in digital world, it is called Boolean algebra, and it is represented same like the normal algebra. We have functions and expressions. So the logic function of this circuit will be called as Boolean expression. Now this is a circuit. Okay, so if any one of you want to write its expression, please let me know. I can make you moderator or center. You can, anyone interested who can develop the Boolean expression for this circuit, or you can just speak up. I will write it for you.
Yes, sir.
Yeah.
First one is input and B input in one logic.
Okay.
Multiplier for B,
Yeah.
and after that C go to direct to output.
Okay. It will be added or what it will do? Add or what?
Add at, I think it's go direct for output.
Okay. You are saying add C. I'm writing it
Yes.
for you. You can correct me if I'm wrong. Okay. Okay.
Sir,
Then what?
I cannot see because I open by phone because microphone for laptop it's not work.
Uh, that's a problem. I mean, you
Yes,
should
I know
use
about that.
laptop, guys. For at least for
Laptop
teaching
it's
sessions. Yeah.
microphone not work there.
Okay. You.
And last one, uh, A multiplier uh, with B, and after that go to output.
Last one, you mean the bottom gate, the
Yes,
gate which is at the bottom. You are saying it
yes,
is also multiplying.
yes, sir. No,
Okay,
not
but
multiplier, but I not know
yeah,
what's.
addition.
Yes, sir.
Yeah, it is doing addition. Okay,
Yes.
but and the last gate which is on the output side, what is that doing? Is that doing addition or multiplication? What gate is that? This one.
Mm,
Is it AND gate? Is it OR gate?
I think or gate
No.
and gate.
Yeah, so what AND gate does? AND gate multiplies. So this AND gate will take all three inputs and it will multiply them. So that's how this logic expression will do. But remember guys, first of all, you need to memorize what type of gate. The number one gate, I'm just labeling. Okay, let me remove everything from here. Okay, three gates in total. So who can tell me what is gate number one? What is the name of gate one? I will write it down here. Is gate one gate, OR gate, NAND gate, NOR gate? Which type of gate is that? Anyone, guys? Yes, Amar. You, Amar, your expression is 50% correct. A little different, but I will let you know. Okay, guys. First of all, we need to recognize the gate types. Okay, this is very important. The one gate is NAND gate. Number two is NOR. Number three is AND gate. If you remember in our previous lectures, I explained that AND gate and NAND gate, they are to each other. Okay, put it with the AND gate, you will come up with the NAND gate, NAND, NAND gate. So anyway, so these are the three gates which are there. Okay, so the first gate, which is NAND gate, it will multiply the two inputs, which are A and B. You can see the A and B are going into that. It will multiply them. Okay, but it will not only multiply, it will inverse their output. Look at this bubble. Can you see there is a bubble? This bubble means a NOT gate is there. If there is a simple AND gate, a simple AND gate multiply A and B. But a NAND gate, it multiply A and B and then it inverses it, which is represented by a bar on top. Okay, inverse means that it will make the output opposite. If the answer is 1, it will make it 0. If the answer is 0, it will make it 1. Okay, so this is what the first gate is doing. Second gate is NOR gate. NOR gate, if you just talk about OR, its job is just to do addition, A plus B. But here it is not simply OR, it is NOR gate. It means it will inverse the output. It will invert it. So we have to put a bar here again on this thing. The third gate is simple AND gate. AND gate job is to simply multiply. Now you can see what three inputs are coming here. The first input is A dot B, which is coming from the first gate, whole inverse. This one, it will multiply. Multiply is represented by a dot symbol. Second input you can see is C coming directly from here. And third input is the output of second gate, which is A plus B whole inverse. So this is the expression. This is the final expression output. This output will be this one. So guys, is it clear or not? Okay, we will do question answer session in our next period. So I will stop the recording here.